In this video, we are going to learn about the applications of differentiation in economics and business, and we will focus on revenue. The price or demand function is denoted as P of X. It is the price per unit for selling X units of product demanded. The revenue function is denoted as R of X. Revenue function is total price or revenue for selling X units of product demanded. Revenue function equals to X multiplied by P of X, where X is the number of product and P of X is the price or demand function. Average revenue function is denoted as R bar of X. It is the price per unit for selling X units of product demanded. Average revenue function is equals to revenue function divided by X. Marginal revenue function is denoted as R prime of X. It is the additional revenue derived from selling an extra unit of product after X unit products were sold. Marginal revenue function equals to the differentiation of revenue function. Marginal revenue represents the instantaneous rate of change in total revenue, and it approximates revenue on the X plus 1 product produced after selling X units products. Or it's simply approximate to R of X plus 1 minus R of X. Marginal average revenue function is denoted as R bar prime of X. It is the additional average revenue derived from selling an extra unit of product after X unit products were sold. Marginal average revenue function is equals to the differentiation of average revenue function. The question for this example is, the management of the Nokia company plans to market the Superstar, a new mobile phone. The marketing department has determined that the demand for those phones is P equals to negative 0.04x plus 800, where P denotes the phone's unit price in RM and X denotes the quantity demanded. Find revenue function. Revenue function is equals to X multiplied of P of X. So now substitute the P of X, which is the price demand, and expand. The question for example 2 is, if the total revenue per month in ringgit is R of X equals to 20x minus 0.03x squared, where X is the number of units produced and sold per month, find the total revenue when 30 units are produced and sold. The total revenue is obtained by substitute 30 into the revenue function, and it equals to 573. So the total revenue is RM 573. The marginal revenue function is the differentiation of the revenue function. The marginal revenue when 30 units are produced and sold is obtained by substitute 30 into the marginal revenue function, and this equals to 18.2. So the marginal revenue is 18 ringgit and 20 cents. Question 3 is, the total revenue is described by the function R of Q equals to 100,000 plus 1,500 Q minus 0.2 Q squared, where R is stated in RM and Q the number of units of product. Determine the number of units of Q that should be produced in order to maximize the revenue function. Hence, find the maximum revenue. To maximize the revenue function means that R prime of Q is equals to 0, or the marginal revenue equals to 0. So, we find the marginal revenue function first. When the marginal revenue equals to 0, the value of Q is 3,750. By using the second derivative test, we can prove that the maximum revenue exists at 3,750. Therefore, 3,750 units of product should be produced to maximize the revenue. Now, find the maximum revenue by substitute 3,750 into the revenue function. So, the maximum revenue is 2,912,500. Please submit this exercise before class ended. Thank you.